Okay, this is the reflections on the coordinate plane. We've talked some about reflections already, but we're going to dig a little deeper into it. Make sure you show all of your work. Stop the video as needed. Rewind it as needed. Have questions, let me know. Just make sure you listen to everything and you show your work. A reflection flips a figure over a line of reflection. In order to create a mirror image. Okay, a reflection flips a figure over a line of reflection in order to create a mirror image. And we've talked about this. If I folded my paper in half, that image is going to lay directly on top of the other image. It's like looking into a mirror. Okay, each reflected point of the figure should be the same distance from the line of reflection. On the opposite side. Highlight and identify the line of reflection for each examples. Okay, so if we have a line of reflection, okay, it reflected from here to here. Your x axis is your line of reflection. Okay, it reflected over your x axis. In this one, if I folded my paper over, there's the line it's going to reflect over, and that is your y axis. Okay, so as long as you understand, the line of reflection is the line it's going to mirror itself over. If I folded my paper this way, that smiley face would come directly on top of this one. This eye would land on this side, this winky eye would land over here, the tongue would land over here. Just folding it in half, it's going to reflect over your x-axis. Size did not change. Same thing with this one. You fold it over your y-axis, everything's the same, it's just mirrored over that axis. Okay, so number one, reflect the figure shown over the y-axis. Record the coordinates of the pre-image and image. Describe any patterns found in the ordered pairs. So, it's important to know it wants the reflection over the y-axis. I want to go highlight the line of reflection. So it wants this image over here. Okay, so we're going to go with our original image, which is your pre-image. Okay, we're going to do W, X, Y, W prime, X prime, Y prime. So my W pre-image would be 1, 2, 1, 2, 3, 4, 5, 6. It's going to be 2, 6. So if it were to mirror over the y-axis, means if it's 1, 2 this way, it's going to be 1, 2 this way. Okay, so what's my image, my W prime coordinates? Well, it's going to be a negative 1, 2. And then it still went up 6. Okay, so let's do X. X is way over here. So my coordinates for X is going to be 7, 4. 7, 4. So if I need that to mirror over here, it's going to have to go backwards 7, but still up 4. That's your x prime. So it's going to go back 7 and still up 4. So I want you to do the y, count your original. Okay, so if you count your original, it is going to be almost the same as w. You're going over 2, but only up 2. So your pre-image is 2, 2. Your y prime is going to be flipped over here to the other side, and it's going to be a negative 2, 2. So as we can describe any patterns found in the ordered pairs, we can. The x value becomes the opposite and the y values stayed the same. So can we represent that algebraically? Yes. What's happening is your x is opposite and your y stayed the same. So you had your x, y, your x, y. Again, that is a reflection over the y-axis. So now let's see what it's going to do over the x-axis. Again, remember, stop the video, write everything I write, show all your work, and highlight the line of reflection. So I want to put my pre-images down. You have to put your little tick marks there because if not, it's going to be wrong. Let's start with D. What's the original for D? Well, we went over 2 and down 2. So we went 2 and 2. Well, that's going to be a negative because we went down. So let's do our new image. Remember, it's reflecting over this line. So it's going to come over 2, but instead of going down 2, we're going to go up 2. That's going to be your D prime. It's going to be 2, 2. So let's go down to E is our next one. So we're going to go over 7 and down a negative 7. So that's going to be 7, negative 7. So if I need to reflect over the x-axis, we're going to reflect up, and it's going to stay on the same line, which is 7, but it's going to be up here, and that's going to be E prime. So then that becomes 7, 7. I want you to do your F prime. So your F prime, again, went over 2, and it's down negative 7. So pre-image is 2, negative 7. If you were to flip it up, it's going to come over here at 2, 7. So if we look at the pattern found in this order of pairs reflecting over the x-axis, we can tell you that the y values became opposite and the x values stayed the same. So the x stays the same, but we went from negatives to positives. So they changed. So x value stayed the same, but it was your y's, because you either went down or you went up, and that is your opposite. So we can write the algebraic expression. X stays the same, your y changes. Okay, so your y changes and your x stays the same. Number 3. Reflect triangle PQR over the y-axis, then describe what happened to each of the coordinates. So if I want this to reflect over the y, remember this is your x, this is your y, I want to highlight the line of reflection. So if it's 1, 2, 1, 2, there's your r prime, and then this one went to -7, so that one's going to go to your +7, p prime. The q came over -5, so it's going to go over +5, and it's going to stay on 7, so q prime. Okay, so again, if you need to look at the front page, you can, but the y values stayed the same because everything stayed up, so your y stayed the same. The x values became their opposites. So x values became opposite. Y values stayed the same. Number 4, reflect your new triangle PQR prime over the x-axis and then describe what happened to each of the coordinates. So now I'm reflecting over my x. So this triangle is going to reflect on this. And remember, if you ever want to check yourself, your line of reflection, fold it on the line of reflection, and those triangles should lay right on top of each other. So this time, if we folded it, we're folding it this way, and that triangle will lay directly on top of the triangle we're going to draw here. So let's look at it. So r prime is 2 over, so we're going to stay 2 over, and it's 2 up, but we're going to go 2 down, stay on the 2. Now then this one we're going to do an r prime prime, because it's the second triangle we're going to make. Okay, so our r, let's put p there, r, again, is going to reflect over. So x's don't change, but it's reflecting down. So we go 1, 2. If it's 2 up, we're going to go 2 down, 1, 2. And that would be r double prime. And then our q prime, it's going to stay on the same line, but it was on a -7, so, it was a +7, so we're going to go down to -7, which is right there. It's the big Q prime prime. So the x values stayed the same. Y values became opposites. So when we went this way, the x's were opposite. We went from negative to positive. But since it all stayed positive up here, the y stayed the same. When we flipped it from here to here across the x-axis, the x's stayed the same and the y's became opposite. Just know where you're going to reflect that image to. What was the line of reflection? Remember, you can stop the video at any time, rewind it, stop it, and do your own work. Number 5, Bella thinks that the transformation below represents a translation. Is she correct? Why or why not? Okay. H, I, G, J. Okay, so G ended up over here. J ended up here. I and H. Transformation below is a translation. The translation, remember, is what we did in the lesson before this. Because it's slides, this means I slide and did that slide over. If I took this image and slid it over here, did everything stay the same? No, it didn't. It can't be a translation because the orientation of the vertices changed. So if it was a slide, H would have been here, I would have been there. G, G, J, J. So it's not a slide. But it did reflect. Or it is a reflection. Okay, so the line of reflection would be right there. It reflected over that line. It was not a slide. Number 6, use the chart to compare the contrast translations and reflections. Similarities, both create an image that is congruent to the pre-image. Okay, and remember what congruent means. Same shape, same size. So that's what's familiar with them. The differences are a translation preserves the orientation of the figure and its vertices, but the reflection does not. Okay, orientation changes. Get my computer back up. Orientation changes. And vertices. means these right here. Like right here, your vertices changed. It went over here. The slide would have kept it the same. So a translation preserves the orientation of the figure and its vertices, but the reflection does not. So the reflection orientation changes and the vertices change. And a reflection. Number 7. Use what you've learned to show where the following points would be after the given reflections. Okay, so again, we are reflecting. If we have a 6 and an 8, remember, if it's reflecting over the x-axis right here, remember what changes. The x stays the same and the y's become opposite. So I'm just going to write x same, y opposite. Okay, and your y, the x is your opposite, but the y stay the same. So x opposite, y same. Or did I just write those on the wrong one? So x is opposite. I think I did it right. Y-axis, x is opposite, y stays the same. Over the x-axis, your x stays the same, your y is opposite. Okay, so let's double check this. So if this is reflected over the x-axis, so we got a 6, 8, totally guessed right there, but it's in quadrant 1. It's going to reflect over the x. Here's my x. So I want it to reflect down here. So your x stays the same, 6, but instead of going up, you're going down, which becomes a negative 8. The y-axis, if your 6x is here, and I want it over my y-axis, we're going to have to go back 6, and then 8. So it's going to stay negative 6, 8. Just think of your line of reflection. So B would be a negative 5, 1. And if it's reflected over the x, here's my x, it's going to go still at negative 5. Positive 1. Okay, so x stays the same and your y is opposite. And then your y-axis, your x is opposite, so that would be 5. It was negative. Now we're going positive over on the other side and still 1, because here's your original. So reflection over the x stays the same. This is your x. And your y is opposite, so negative 9 becomes positive 9. Over your y-axis, here's your original. The x is your opposite, so negative 10. Your y is the same, negative 9. Always remember you're looking at your pre-image. So again, x stays the same, so -4, and the y is opposite, so that would be 11. Reflection over the y would be your x is opposite, and your y stays the same. I want y'all to try to do this one by yourself. Look at the rules up here and put it down, but always look at your original. Okay, write in your own words what happens to the coordinates if a figure when the following occurs. Okay, reflection over the x, reflection over the y. This is kind of a summary of what we just did, but this is in your words. Okay, so remember, when it reflects over the x axis, the y values become their opposites. The x values stay the same. And then when it reflects over the y-axis, the x values become their opposite and the y values stay the same. So put that in your own words. And when you're done, make sure your name is on it, the date's on it, and turn it in.